Well, now let's go to level 3 statistics. This is the other probability distribution paper. This deals with formal distributions rather than just probability concepts. This is worth 4 credits. So I'm going to just go through this the first time I've seen it. I'm just going to use the formulae that are given to us. This is the one that you really do need to use this formula booklet, I'd say. And I'm going to use the most common calculator that New Zealand students use, the FX Casio calculators. So let's do it to it. All right. Question 1. The length of posts on social networking site X, previously known as Twitter, tends to follow a normal distribution. Right, okay. Where most posts have average lengths. So that's what we're doing here. We're dealing with a normal distribution. Most posts have an average length. Very few short or long posts. Okay. The parameters will depend on the platform, the specific group of users. One group of X users, the average post, okay, so average is 150 and standard deviation is 30. So from that, we can draw it's normally distributed, and the average, the mu is 150, and the standard deviation is 30. Let's say, I mean, there's a minimum and a maximum. I think it's a bounded thing. Is you certainly can't have negative words in a tweet. I think there's a word limit, right, for your count, the number of characters. But okay, so a short post is a post that has fewer than 80 characters. Okay, use the normal distribution to estimate that the probability is not short. All right, so let's break this down. So normal distribution, it's kind of getting our heads here. It's the bulk here. It's going to be, so 1 standard deviation, and here we want 80. So we want that it is not a short post, so we want all of that. So we are going to go to our calculator. Now, the later models of this calculator and the models with the updated software on them have a special mode which does this all automatically. It doesn't have it on this emulator, and I'm going to use the stats mode anyway to do it. Okay. I think okay, so let's go to stat mode, and we're going to go to distribution, normal distribution, and we are going to go to cumulative. This is, you never need to use this one. We use the cumulative for this instance. The lower limit is going to be 80, of course. The upper limit, let's set it as something crazy, 500. The standard deviation, they tell us, is 30. And the average was 150. And we're going to get that. So the probability that it's in that group is really, really huge, like over 99%. So what I'm going to do in this exam, I'm going to go 4 decimal places for everything, I think. So probability, the probability is going to be equal to 0.992, according to this calculator, 40p. And that's it. That's all you need to do. Just extract the information, maybe explain what you're doing, but this is the answer that you're looking for. Next question tells us that 2 posts are chosen at random, and estimate the probability is that one post is short and the other is not short. So this is a binomial distribution. So it's binomial because there are two outcomes. The events are conditional, the opposite of conditional. They're independent. And there is a known number of outcomes. Known number of trials, sorry. So there are two trials. In this case, the probability of a success is going to be 1 minus 0.9902, which is what we just worked out. Or it doesn't actually matter in this case because it's going to be symmetrical. It doesn't really matter which way you go because there's only two trials and two outcomes, so you get the same result. Let's work it out more over here. You're going to say a success is under. Yeah, okay. Let's say a success is under. So 1 minus 0.9902 is a really, really tiny number. So let's go with no way around actually, because it's just there's more chance for scribes to do that. So let's write that out. It doesn't matter because one is long and one is short, or one is normal, one is short. It's going to be the same. So there are two outcomes, and the one that was looking for is one. We're looking for one, and it's going to be one. Menu distributions, binomial, and we are looking for a PD. It's a discrete distribution, so we're going to use just the variable. The one we're looking for is one positive outcome. The number of trials is 2. The probability is 0.9902. And the probability is really, really, really tiny. So 0.194. 0.194. Fair enough? Okay. Let's move on. So the assumptions we need to make. So choose from, we need to work out their independent outcomes. They're not related, in other words. We have to presume that the outcomes are mutually exclusive, which E mutually exclusive. What else do we need to do? We need to presume that it's binomial. We need to presume that it's random. So we're not kind of going into one particular person or choosing something stratified. We can have a sample set, and every outcome is going to, every trial is going to have the same. So every trial has the same probability. So how would that affect things? Any one of these, and it doesn't work, binomial distribution cannot be used. Okay? We have to find something else. As the probability is moving around, then by definition, if the probability is not fixed and it's moving around randomly, then we can't guess the probability itself is moving around every time we test it. It's going to be an exercise of utility. So now we're asked to comment on the fact that the maximum number of characters that can be used in the next post is 280 with 3 count holders. And we told this normally distributed, so why wouldn't that affect this group we've got? Well, if the maximum is 280 and the average is 150 and the standard deviation we're told is 30, then that's what? Almost 4 standard deviations above the mean. Okay, so if we went to our formula sheet, which I'll just grab. So now we're told that Instagram users from this group of X users create at least 10 posts per week. They've never used Instagram in my life, but okay. 10 posts per week and no more than 130 posts per week. Sketch the distribution of the number of posts. So first thing we have to ask is what sort of distribution is this going to be? It's not going to be binomial or Poisson distribution. It's also not going to be normally distributed because we're not given the mean or standard deviation. It cannot be triangular distribution because we don't have the most common. It kind of implies that anywhere between 10 to 130 can happen. And that would tell us that this is a uniform distribution. So the uniform distribution, the probability of every outcome is just as likely. So let's say it's 10, 20, 30, 40, 60, 80, 90, 100, 10, 20, 30. Look at that. Suspiciously good for us. So the probability is going to look like that. It can occur anywhere on here and they're just as likely. So what's going to be here? Well, according to the notes, the probability is 1 over B minus A, where B is the biggest number possible and A is the smallest number possible. 130 minus 10 is 120. So this is going to be 1 over 120. So every outcome has the same probability of 1 over 120. Don't know whether you need to put that in decimal form, but that's what it is. Now we're told that given a particular Instagram user creates fewer than 120 posts in 1 week, estimate the probability that they create more than 50 posts in a week. So in other words, we're saying the probability that they create more than 50, given that X is less than 120. Okay, so if we look at our model here, so 120 is here. So effectively, we're going to cut this off here. So this is gone. And we want to know everywhere from 50 to 120. So 20, 30, 40, 50. So in other words, we want sort of this area. We want that area there. All right. Well, we can just do that really by eye. There are 11 sort of lots of 10 here. And 1, 2, 3, 4, 5, 6, 7 of them. 7 of them are taken up by what we want. So the probability that it's between those two is going to be 7 over 11. We can just go straight to the answer in that case just by reading off the graph. Doing the graph makes it a lot easier for us. So 7 divided by 11, what a decimal is 6364. Remember, we said we're going to go to 4 decimal places. That's it. We don't sort of overcomplicate it. Just read it carefully and ask exactly what they're wanting to find out. And it's the same group as this, but they kind of cut it down a wee bit on this end, and they want you to disregard everything from here. On to question 2. For adult social media users, some users report most common age is 30 years old. They sample 131 section. So the most common age is 30. Sounds like a triangle coming up. They sample 131. between the ages of 17 and 2 was taken. And then we show in this, it looks like it's 5-year lots with the frequency up here. It is claimed that 35 to 40% of social media users are between 25 and 35 years old. Does the data support this claim? Okay. Let's get the calculator out. So between 25 and 35, but then here's 25 there and there's 35 there. So it would be those two pillars there. So 26 plus 22 out of it's given as 131. Is that between 35 and 40%? It is a question. Okay, 26 plus 22. So 48 of them are between those ages. Divide that by 131. So 0.364, 664. So that's 36.4%, which, yes, okay, that is definitely between 35 and 40. So really easy for level 3 question. Okay. So now we're asked to discuss the triangular distribution of this model with the parameters of 17, A for 17, B for 82, and C equals 30. Justify the choice of the parameters. Well, for this one, I mean, it's explicitly stated. So the lowest age is stated. 82, this is the highest age, and they explicitly state it. And let's look at the wording that they used for 30. So 30 is the most common age. And if we look here, so this is between, so this is 25 is here. So this is the 31. So it is the most common age, and it does have this triangular shape. There is a bit of a hiccup here, but it does tend to have this triangular shape. So it's stated as the most common, and it's the mode. Comment, it does have that shape, that triangle shape. So it's not like curved or anything like that. That's not in it. It does tend to it's interesting. It does tend to have that shape. And that's about it. That's about all you can say about it. Here's what they give you in the tables. So A is most definitely the lowest one and stated, and the most common is C, and the highest number is B. And it is definitely that shape. If you have a look at the shape, you can do that shape here. Okay. Now we're asked to work out some cumulative distribution using the data that's been individualized. So use this triangular distribution model to estimate the probability that a randomly chosen social media user is more than 35 years old. So probability that the user will click X that is greater than 35. Right, given that A is 17, B is 82, and C is music. So obviously they want come back this area here. Well, they kind of spoon feed you the answer there. You just have to look at the formula. So which of these is the one we're looking for? So it's between C and B. So it's that one there. So it's going to be 2b minus x, and x is the number that we have somewhere. So x is going to be 35 is over b minus a times b minus c. So let's work it out. So 2 times b is 82 minus 35. B is 82 minus a is 17 times 82 minus 35. Grab your calculator and crunch the numbers. So let's do the numerator first. So 82 minus 35 is 94. Then the denominator is going to be big on side. So brackets 82 minus 17, 82 minus 35. I really like these Casio calculators. So you can just put it in as it's seen there. And 3055 and expect to get the right answer. Just a word though, advised to use brackets, parentheses if you're in America. And it's not, they should do something sometimes. So that's a really, really small number. So 94 divided by 3055 is, okay, so that's not the distribution between 35 and 82. What this is the distance from here to here. But we want this distance here, so we're going to need to use the geometry on triangles. The area of the triangle is half the base times the height. And the base is the base, because we can't say B. The base is going to be 82 minus 35. And the height is going to be this. Let's do it exactly 94 over 3055. So the probability that someone chosen at random is greater than 35, then it's going to be half times the base, 82 minus 35 times 94 over 3055. I'm going to do that in here and calculate the time. So half 0.5 times 82 minus 35 times 94 over 3055 equals 0.7231 40p. And that's our final answer. So let's highlight that. So use your answer from the one we just did there and observations from bigger ones. Just comment on the suitability of using this kind of distribution for the data sample. Well, I'd say it's pretty good. The shape is pretty good. So it is pretty triangular. The thing which may sort of skew it is that A2 figure. It does tend to sort of go like that, and then there's this sort of blip. Yeah. So maybe if we had not included that A2, maybe it would have been a little bit more exact. But I mean, the proof is in the pudding. So let's do a little test. Does the hypothetical probability equal the observed probability? Let's test that. So the probability that the hypothetical probability that we worked out that something is greater than 35 is 0.327231. The observed, let's work out how many are greater than 35. So let's go to the table itself. So here is 25, this is 35. So how many of them are greater than 35? Let's add them now. People here. So here it's going to be 16 plus 16 plus 13 plus 7 plus 6 plus 3 plus 1 plus 1. So 63 of those pins are older than 35. And how many were there to begin with? Like, so we have to scroll back up to the top. There were 131. Over 171. So let's work out how close are these? So 63 divided by 131. I think it's probably going to be a bit low. Yeah, 0.48. 0.4809. So it does, one has the right shape, let's say correct shape, the hypothetical, or let's say theoretical probability is greater than the observed. And this is probably due, because it's geometric, to the highest number, 82, really being an outlier. And it does tend to skew there and tend to have too much leverage over the final outcome. That would be, so kind of a cheap question would say, you'd say, well, just looking at the shape, yeah, it's a pretty good shape. Sort of a merit plus answer will kind of put a bit of a question. It's definitely the merit stage excellence question. The average age of the sample of meeting is 37. So it's new equals 37. No individuals are aged less than 17, so there's a limit. And only one individual is above 17. If the normal distribution, so we're going to be dealing with a normal distribution, is to be used to model the ages of media, social media users, calculate the minimum standard deviation that fulfills both of the following constraints. Probability of less than 0.001 of a randomly chosen social media user being less than 17, and probability less than 0.01, so 1 is 0, being age more than 17. Okay, how are we going to solve this one? We know that Z is X minus mu over standard deviation. We're wanting to find that standard deviation. Okay. We are given two X's in this case. X is 17, 70. Each of those is going to have it's going to require a different Z level. The Z level goes with the amount of standard deviation. The mu is given to us explicitly as 37, and that's not going to change. How are we going to find the correct Z-score? Well, you could use the tables. My bias is not to use the tables. My bias is to use your calculator. There's just less chance for I don't like using the tables. They're very inexact. You have to kind of fudge around a bit to find the numbers. There's a lot less monkey business when you use your calculator. If you don't know how to use the calculator to find Z-scores, I'll show you now. A Z-score, remember, belongs to the standard normal distribution. In the standard normal distribution, the standard deviation is 1 and u is 0. And the z is equal to the number of standard deviations away from the mean, from the mu. And if it's to the left of the average, z is going to be a negative number. And if it's to the right, it's greater than u, z is going to be a positive number. So with that said, let's use that in our calculator to work out the z that we would need to work out the different standard deviations. So we're going to take our calculator and we are going to go to the stats mode. We're going to go to distribution, normal distribution as per usual. And because we're looking for areas, given the fact that we know what our boundary numbers are, we're going to go to inverse. And here it goes to, I think by its default settings to this one here. So we are looking at the left-hand side. We're definitely looking 0.001 belongs to 17. So we're going to go to the left-hand side. The area that we want is going to be 0.001. The sigma, the standard deviation, is going to be 1. U is going to be 0. We're going to enter equals, and it's going to give us the z-score that we want. It has x there, but x is the number of standard deviations. That's the z-score that we want. So rather than playing around with the tables, you can enter the z-score. So the z-score that goes with the 17 is going to be equal to, let's display on my screen, negative 3.0902 for decimal places. And the z-score that goes with the 17, it's going to be different because that has a different area. So we're going to X that up there, and now we want the right-hand side. And the area that we want to find is 0.01. And sigma and mu are going to be the same. We're going to hit X, enter, and that's the z-score now that we want. Basically, just practice before you go into the exam doing this. It's a really good and useful trick to know. So the number that we have for the z-score that goes to 17 is positive 2.3263. Okay, now it's an algebra problem. So let's work out what our standard deviations would be in each of these scenarios here. So you know that z is x minus mu, have a standard deviation. For the 17, the z-score is going to be minus 3.0902. We want the bottom 0.001. It's going to be equal to the x-score, which is 17 minus 37 over sigma. So our sigma, remember your algebra, is going to be equal to 17 minus 37, which is minus 20 over z, which is minus 3.0902. And now we can work it out. So in this case, if we wanted to have less than 0.001, less than 17, so 6.47, the standard deviation would need to be less than 6.4721 would EP. Same point here. Z is 2.326. So it's 2.3 standard deviations above the mean. is going to be equal to x, which is 17, minus mu, which is 37. So this is going to be a positive number divided by its standard deviation. So in this case, the standard deviation, this is 17. Standard deviation that goes with the 70 is going to be 70 minus 37 divided by 2.3363. So that's going to be 33 divided by 249. Right, so we have two different standard deviations. This one gives us, we exclude the top or the bottom 0.001, and we exclude, in this one, the top or the bottom 0.01. Less exact, 10 times less exact. Which one are we going to use? Let's have a look at the wording of the question. So we want something that gives us less than 0.001 and less than 0.01. We're going to choose this one. Because this is, if we chose this one, when we came to, it would work fine if we were looking for numbers greater than 17, and it wouldn't find us numbers less than 17 at this precision. So we're going to use, so the standard deviation we use must be less than 6.4721, and that's our final answer. I guess you could say the standard deviation would have to be equal to that because it says what's the lowest number. So I guess you could say less than or equal to that number there. And then question 3 now. Social media platforms, TIGs used to generate content using an automated system to identify potentially harmful or inappropriate posts. 3. Elon Musk times the population of posts where 1 in 10 posts contain harmful or inappropriate content. Yep. Social media is just a cesspool. Every malaprop in the human race, they got that right. The automated system is used to screen 20 posts created by one user for harmful. So the automated system, it's really bad to read it. The automated system is used to screen 20 posts created by one user. So did this one user create those 20 posts? Or did that one user create the automated system? I think it's the one user creates the 20 posts. Use the probability distribution to estimate the probability of observing fewer than 3 harmful or inappropriate posts. So there's problems there. This is the one user is creating these 20 posts. It's really, we want to be looking at the user rather than the posts they're making, but let's go with it. It's binomial. So binomial, there are 2 possible outcomes. The outcomes are independent and the number of trials is not. So what's the probability of one of the posts in one trial being harmful? Well, the probability of being harmful is 0.1. It's 1 in 10. The number of trials is 20 because they go through 20 of these posts. And the number that we're looking for is less than 3. Less than 3. So we need to sort of note that because the calculators do tend to, there is a little bit of a trick with that. All right, let's go to our calculator and put in those numbers. We're going to go to stats mode, distribution binomial. We are looking at cumulative because we're looking at more than one. We want variable. Now, the number that we're looking for this is not 3. It's less than 3. And it is a weird quirk of these Casio calculators. But that means for here, we're going to need to put in 2. It's a discrete distribution, so they're in lots of, they're in integer values. What it means is that if it's 2, that means it's 0, 1, or 2. And it will automatically add them up. If you put in 3, you'll get the wrong answer because it will include 3. It can't include 3. It's less than 3. Number of trials is 20, and probability of getting a hit, success, one of those trials is 0.1, like a 10. And so, probability of getting less than 3 is this number here, 0.67. So the probability of less than 3 harmful is 0.67. I actually round to 4 dp. So it's a binomial with those parameters. So here we get to the point that I was making before. So to apply the distribution used in part 1, part A, to model the behavior in appropriate posts, an assumption of independence is made. Describe this assumption in context, whether it is valid to make this assumption in this situation. Well, it comes from one user. So that's important. So let's just define independent. It means that each trial has the same probability, and the probabilities do not change. Right. Is this true in this case? Well, it might not be true. What if this user is, let's take case A. What if this user is a corporate account, and the last thing they want to do is put offensive or insulting content on? So you would say, I'm not sure what the use of that, an anti-troll, a normie, okay? What if, though, this person is a troll and they're actually trying to get a reaction? You're watching this on social media platforms, so you obviously use social media. You know what cesspit social media can be. And there are some people who just go out of their way to put these sorts of posts on. So it's probably not independent. Fair enough? Okay, let's move on. The next question, the system reports false positives, meaning that a proportion of harmless content is mistakenly identified as inappropriate at this experience. Do something and it gets flagged and it's completely obnoxious post. The table below shows the probability distribution that a random variable X of false positives reported per batch of 100 posts. So in other words, we got 0 false positives 12% of the time, 1 false positive 0.27% of the time, and so on and so forth. How many false positives on average are reported in the system of a batch of 100 posts? How are we going to work it out? If you look at the formula, it's that. And the mean is going to be the frequency times the probability, the sum of those. So how are we going to do that? Well, it's going to be 0 times 0.12 plus 1 times 0.27, so on and so on and so on. Another way we have of doing it is using the calculator. We can just put these in. This is the X that we're looking for, and this is really the frequency. So in the calculator, if you go to menu, stat mode, you'll see what I've set it up here already. So 0, picking at a frequency of 0.12 of the time. Now, if you go to Shift, Setup, Calculate, you go to Shift, Setup. Yeah. Yes, you set the variable 1 is X, X list 1, and the frequency is list 2. So just again, that's X F6 set, and it's going to be the same as that. Now, if we go to one variable, so it's going to give us the mean, the standard deviation, the mode, etc. Gives us 2.1. And that's our answer, 2.1 times per 100. So discuss why the Poisson distribution may be useful for us in this time. Well, we're presuming that the events are, yes. The events are rare, yes. The events have set probability, that is, that they don't sort of evolve over time, yes. And there is a relatively large population space, yes. It needs these four things really to be in order for the Poisson distribution to be useful. Last question of the exam. The competing social media screening system states at least one false positive is found in 97% of the batches of 100 posts. Calculate the false positive rate for the screening system and use this calculation to comment on the accuracy of the competing system compared to the emerging system from part C. So this is a really quite involved question. You either kind of know this or you don't, but you can use your tables to get the first bit anyway. So these are from the formula tables. Again, it really behooves you to know what's in these formula tables for the exam. Without them, you're going to be pretty stuck. So we are going to use this one first. So when you put the numbers in the calculator, this is the sort of calculation that it's doing. This is the grunt work that you're going to see. All right. For this one, then, they want to know calculate false positive rate for the screening system and comment on the accuracy of the system over 100 trials. If it is getting it right 97% of the time, so it's getting it right 0.97, that means that it's missing 1 minus that, isn't it? Which means it's missing 3% of the time. So we are going to use this one here and this one here to work out what the probability is. Now, the probability that we're trying to find, they give it as pi. Think of this as the probability really that we're trying to find. And now, if you want to use your calculators to do that. N is going to be 100. X is going to be 0 because that's all we're trying to find. How many times it gets it right? Or how many times it gets it wrong, sorry. And N over X, assume this one here, so it's going to be N choose where it's going to be N choose X. So it's going to be 100 choose 0. So anything choose 0 is going to be 1, but let's prove it. So how do we do it on these calculators? We go to the main screen. then go to option, probability, and here it is here. So 100, choose 0 as 1. So using this from up here, n, it's going to be 1. So 1 times the probability of the lifetime to the power of 0 is 1 times 1, which is 1. So effectively, this sort of cancels. It just gives us 1. All right, now 1 minus the probability that we're looking for to the power of 100 minus 0 must equal 0.03. So now we have one equation and one unknown. Right, that means that 1 minus pi must be equal to the power of 0.01. We take the 100th power, in other words. Let's work that out on the calculator. 0.6955. So therefore over. So negative pi, it must be equal to 0.9655 minus 1 is that. And then of course we're going to multiply that by negative 1 to get. So the answer that the number of false positives that we get, probability of false positive for each trial, for each participant in this is going to be 0.3446. Okay, that's the answer that we're looking for. How does that stack up? That tells us that, oops, I made a mistake, phi is 0.0316. So that tells us that pi times 100 is going to be 3.46. How does that stack up to the last model? Well, the last model, there was an average of 2.1 false positives. This one averages 3.446 false positives. So therefore, this system is not as good as the previous system. So a lot of algebra there. This is very definitely an excellence question. You need to sort of know what these symbols mean. They do throw kind of reach and works there by using pi instead of p. And then they give you this, and if you didn't know that this was here, you'll be able to do it. But once you've got to here, it's really an algebra question. Okay, so that's the end of this exam. Okay, kind of this funny exam. Some were really easy, some pretty tricky. So you could probably expect a high amount of passes. Probably quite a few people got tripped up by the trickier question. So all in all, pretty good. Hope you did well.